Today we're going to do a quick recap of center of mass. The way I like to look at center of mass is it's the point on an object where you can balance it on your finger without it moving right, left, or falling off your finger. The way to do this is you got your center of mass, you got your X and your Y center of mass. For linear objects like a piece of wood, you would only have the X center of mass, but for objects that have a Y and an X axis, you have to do an X center mass and a Y center mass, and you'll get your X and Y coordinates that you can find the center mass with. Both of these follow the same equation pretty much. You got your mass times mass of one object times its position, its X position in this case. And then you keep on adding your second mass times its X position, and so on. And keep on doing that, and then the bottom is just going to be the total mass of the object. So you keep on doing that for as many objects as you have. So for this one down here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have nine objects. So you take each one of those and you to the top, you do mass of one and its position on the x-axis. The second one is mass and its x position over all the masses added together to get your x center mass. Your y center mass is the same thing pretty much. Mass doesn't really change, but you take its y position now. And you keep on doing that as many times as you need to. For as many objects as you have. And that's the equation for both of them. Physics notebooks like to write it like this. They write it in a weird way here. But pretty much that just means this. If you see that, it's just the X center mass equation. So let's do a couple practice here. Let's do this one first. I like to put my center mass on the most objects possible, because if the way you look at it is the more objects that go through an object, so the X is like 0 and the Y is 0, and you won't have to calculate them. So this one here, remember each one of these blocks is its own object. So each block has its own center mass, which is the center. So center mass here, center mass here, center mass here. So its X position is going to be where its center mass is. So each one of these, let's say, is 1 kilogram. Doesn't matter what unit you use for mass. It doesn't matter what unit you use for its X and Y position. It can be meters, inches. Just make sure you record your answer that way. So this one, it's 1 kg, and it's going to be 1 kg in the center of this. And let's say each one of this is 1 meter long. So I'm just going to draw a line through the center of that, and then through the center of those. And so let's do, this is going to be your Y, that's going to be your x-axis. Just like a graph. Let's do X first. So you got, you start at 0, and you got 1, 2, 3, 3 kilograms at 0, and then you get 1 over, and you got 2 at 1x, and then you got 1 at 3x, and then you got 3 at, sorry, this is 2x, my bad, and then 3x. And then there's 9 of them in total, so I believe there's 9. I might have lied. 3, 6, yep, there is 9. And so let me plug that in my calculator real quick. You got 2 plus 2 plus 9 over 9. I got 13 over 9. Then y, you do the same thing. You start at 0. You got 4 at 0. Plus 3 at 1. And then 2 at 2. Over, still 9. The center of the mass of the whole object. So you got 3 plus 4, which will give you 7 over 9. And so your center mass is going to be 13, 9, comma, 7, 9. Then you go up to the graph here, and 7 nines is about, 13 nines, my bad. 13 nines is about 1.5. So you go, start at the origin, over 1, over 0.5. So it's going to be like there, and 7 nines is going to be right about there. So that's your center mass. And then they'll take it into more linear objects here. Like you got a piece of wood hanging out of strings. Most of the time the strings are massless, but most of the time the wood has mass that's holding these two objects together. So center mass of the wood is going to be in the center. And that can be whatever you want it to be. So I'm just going to put my x-axis, my x and y axis here. And so you are going to have a few negative numbers, but if you just start at the origin when you get your point, center mass point over here, it still should get you that same answer. You can put your x-axis and y-axis wherever you want. I just see it to be more easier here. So we can do our x center mass. Let's say the wood is 2 kilograms or whatever you want to say. So 0 right here, there is 5 kilograms, and then we go over, because half 3 is 1.5, so you go over 1.5, you got 2, you go over 3, and you got 6. Over the total, so 5 plus 2 plus 6 is 13. And y center mass is going to be 0, and there's going to be 2. You go down 1. It's going to be negative 1, so it's going to be negative 1 times 5. And then that's going to be negative 2, because it goes down 2 times 6. Divide the whole thing by 13. So let me plug these in real quick. 3 plus 18, so you get 21 over 13 for your x center mass, and then you should get a negative for this one. You get negative 5 minus 12. So you get negative 17 over 13. I usually keep them in fractions, but it's easier to find where they are on the grid. So it's going to be 1.5, and then it's going to be 1.5 over on the x, and then it's going to be like 1.3 over here. So your center mass is going to be there. That should do it for center mass. Just remember, units don't matter, and put your x-axis wherever you want. Just don't forget to make it negative if it goes below y or to the left of the x.